With the start of Project 12-2, I'm just going to have my CentOS 7 running and do the lab. Towards the end of the lab, when it says to do this on the Ubuntu server, I'm going to shut down CentOS 7 and edit the network configuration for CentOS and Ubuntu and then bring them back up. We'll change it from a NAT adapter to a bridged adapter for subsequent labs in this section. So I'm going to log in to the desktop and bring up a terminal window and log in as root into the terminal window. This lab covers name resolution. When you type in a web address such as www.google.com, computers don't understand the text google.com. They have to ask a server to translate that into an IP address. So here I hit activities, I click terminal, and I'm going to do an SU- to log in as root and enter pass1234. Now we'll look at the host name of the computer. It's stored in the hostname file under the etc directory. It asks us, why is it server1.localdomain? Well, during the installation, back in chapter 2, I believe it was, we specified server1 as the name of the server, so it is stored into this file. The next one, looking at the resolve file and seeing name servers and your domain. If you're at home, yours will be different. You'll see the possibly 1 or 2 name servers from your ISP listed. So this is whenever you type in, say, google.com, you go to one of these servers and it will resolve that to an IP address for you. And we have multiple ones. Just in case one of them is down, you can try the next one. Here on campus, we have 3 for backup purposes. The next thing to look at is the name server switch.config. If we look at this and we scroll up a little bit, I think it told you to actually use less instead of cat for this. So you should be able to go up and down if you use the less command instead of cat, or the scroll bar if you're in the graphical interface. We have a host section here. It tells us to look at files on the system first, and then look at an external DNS server. So let's look at the files. What is that? I use cat etc/host. That file is the one that contains IP address followed by name or names of a computer. A computer can be known by multiple names on a system. As long as you have the IP address and a name or several names spaced out after that IP address, that computer can be identified by any of those names. Here we have localhost, localhost.localdomain, and we could also put in here our server1.localdomain if we needed to figure that out. This file also exists in Microsoft Windows. If you were to bring up Explorer on your Windows machine, go into C drive, go into your Windows folder, find System32, go under drivers. Yes, Windows buried the fact that their code base started from Unix. There's the etc folder in Microsoft Windows. One actually exists. Not much is in here except for the network protocol. So here we have host. I'll open it in WordPad. As you can see, it has basically the same thing that Linux had in it. A few years ago, viruses used to put in 127.0.0.1 and list all of the Windows updates and antivirus company websites out there. So when the virus is on your system, you could not access them because it would just point back to yourself. So we had to edit this file, delete all of the virus junk that was in there, so we could download a tool to remove the virus. So yes, that is in Windows 2. And you can do the same thing in that file as we're going to do here in step number 5. We're going to edit the host file with the VI editor, and we're going to insert, go to the end of the line, and put in a new address, 1.2.3.4. I will tab over and put in fake host.fakedomain.com space sample. So 1234 is associated with sample or fakehost.fakedomain.com. Hit escape, :WQ, and we need to ping it. We're going to use -C 5 and tell it to ping 5 times. And we're going to ping the local host. So there's the 127.0.0.1. As you see that in the host file up above. And we're also going to try to ping, you can try to ping sample, or you can try to ping fakehost.fakedomain.com. And now we'll be coming up to when you take a screenshot here in a little bit, it will error out. It does show that it is resolving to 1234. But of course we're not pinging anything because there's not a computer at 1234. So it fails because it doesn't actually exist. So you take that screenshot, and then you go ahead and do the ping for sample. You'll get the same output. I'm going to use Control-C to cancel that because it's not going to work. Now, we are still using NAT, so we have a 10-dot network most likely for your VirtualBox. We need to fix that for the next section so that we can communicate with CentOS and Ubuntu from Windows and from CentOS to Ubuntu and vice versa. So power off your virtual machine after you've got the screenshot. Once they are powered off, in Oracle VirtualBox Manager, you're going to want to click on CentOS and Ubuntu, and under each one go under Settings, click on Network, and change it from a NAT to a bridged adapter. So I'll do that for Ubuntu. Network, NAT to bridged adapter, and it should show your Ethernet adapter, or if you're using wireless, it should show your wireless adapter in the list. With those selected, I will start them back up, both of them, because we're supposed to do steps 2 through 9 on Ubuntu, just to see the similarities between CentOS and Ubuntu. At this time, go ahead and pause the video and do these steps on Ubuntu. You should get the same output as you did on CentOS. And then we'll move on to 12-3. Once you've completed the steps on Ubuntu, move on to 12.3. Again, you'll be on Ubuntu again. Log in as root and pass 1, 2, 3, 4. If you didn't log out and are still root, that's fine. Here we use a couple of commands. We use a host command to find information about a computer. This tells me all of the IP addresses associated with ftp.kernel.org. There's another tool for looking up, and that is the Nslookup. You'll find this in Windows. It gives me about the same output. And then we have the dig command which is the preferred command for Linux. Gives us a little bit more output, a little more detail separated out. So they all do basically the same thing. Tells us the different IP addresses, and the dig command is showing me that ftp.kernel.org has a CNAME of ftp.all.kernel.org. Whereas I believe if we look at the commands above, they didn't tell us that, the Nslookup did, so the canonical name, or better known as an alias, is ftp.all.kernel.org. So it's just letting us know that the computer is known as, can be accessed by two different names. A command that they leave out is whois. You can get this from the internet. You can go to the ARIN, the Internet Registry website, and check for who has certain addresses. Or you can use it from a Unix Linux command line if it's installed. I'm going to install it for Ubuntu, so I'm going to do an apt-get install whois. So with that installed, I'll type in whois space and the IP address. I'm going to use the last IP address in the list. Yours may be in a different order. So that was for the ftp.kernel.org, one of their addresses. I'll hit enter, and the information given here is who registered this block of addresses. It tells me the address, tells me when it was registered, when it was updated, the company. It normally will give a telephone number for contact. There's the organizational telephone number. So if you're being hacked from an IP address and you look up the whois information about that, and you find that the address is coming from North America, Britain, Canada, then you're likely able to call and get something done about it. Probably somebody has hacked into a company's computer or one of their customers' computers and trying to hack your system. So making a phone call, letting them know that here's the IP address that's hacking, then that can be solved. We've gotten calls before. They call ASU Jonesboro. We'll look at whois for one of our addresses. So this comes up and it gives me the network administrator, several different network administrators here, and the telephone numbers. Notice it's an 870 area code for Northeast Arkansas and Eastern Arkansas. So calling one of those, that gets me onto the Information Technology Services for Arkansas State University at Jonesboro. And I'd let them know that, hey, such an IP address is hacking. They would look up which subcampus that address went to. They'd call the IT. If it happened to be that 16.1, that'd be ASU BB. So their IT department would call Chris Lee here on our campus, and he'd figure out what address that was and track it down and rectify the situation on that computer. Okay, the video is getting a little bit long, so I'm going to look here. What is 12-4? Looks like IP route. We can go ahead and do IP route on our CentOS before we stop the video and move on to 12-5 on a second video. So this one, we go into CentOS and add a route. If you're in Cisco, you should understand routes. If not, hopefully you'll take some of the Cisco classes and get more information. I'm not going to go too in-depth on subnetting and IP addresses because that is covered heavily in our program in the Cisco. But as you see, if you're taking Cisco, it is used everywhere else in all your other classes. So let me log back in as root. And I'll type in route. Here I'm not getting the expected results. If you're taking Cisco class, you know the default gateway address needs to be in the same IP address range that your IP is set. Since we set it to bridged, I now have a 147 number. You will likely have a 192.168 number from home. I'm going to type ifconfig and verify that my Ethernet is a 147 number. So I'm having an issue here with my gateway. And on my command prompt, if you remember from 12-1, there's a configuration file for our ENP0S3. It was under etc sysconfig network scripts. And then ifcfg enp0s3. So I'm going to edit that file. You may have the same issue. Looking at this file, protocol's DHCP. That is good. I go down and I see that there's an address though. So I'm going to go down toward IP address 0 and hit DD, the prefix 0, hit DD to delete the line, and the gateway, I'm going to hit DD. Those should not be set since we were getting DHCP. So now I did not go into insert mode. I'm going to hit :WQ to write and quit. I'm going to use the system control command. Now I'll try to type route, and I'm getting the expected results. So for some reason, those static addresses were kept in the file. Maybe a security feature of CentOS or possibly even a bug. We have not updated CentOS from the base install of it. They have lots and lots of patches out for CentOS since it's been out for about a year now. So now I've got the correct information on my default route, default gateway. So record down your default gateway address. Should be down to just 2 lines. So default and your gateway, that's what we're going to need in step number 3. The GWIP is in red. You're replacing that text with this number that is on your screen, not the number on my screen. So IP route add 1.0.0.0/8 via, notice I'm not putting GWIP, I'm putting 147.97.16.1. Again, that will be different on yours at home. And type in route again. I see the route is going to go to 147.97.16.1. If anything goes to the 1 dot network. They ask, will this interfere with traffic going to that network? No, it will not. Any traffic going to 147 network, my local, will notice it's zeroed out. It just stays on my local LAN. It doesn't need to be picked up by a router. But any other address will be picked up first by default or the 1 dot, and it's going to go to the router. So because either one of those is not on my network, it needs to go to the router. So nothing will affect that. The next 2, trace route and trace path, likely will not work. They have added security onto the internet routers that block ping. So you may get a little ways out and then you'll start possibly getting no replies because you're going to hit routers over the internet that they have added security to block all ping traffic to the router. Use my left control key and C to break out. So those used to be really great troubleshooting commands, but hackers and bad people in the world have eliminated useful tools for us, just because they use those tools and change the packets up to destroy things. Number 7, both of those should come out to be 0, showing that no, your system is not set up as a router. Okay, I'm going to go ahead and stop this video, and you'll definitely want to watch the next video on Telnet.